Okay guys, so this is going to be unit 4.3, and this unit is just going to be a lot of graphing practice, just making sure that all the concepts that you had before are kind of understood, and if they're not understood, understanding them as you're completing these problems. With that said, I want to make sure that we clear up a couple questions that you may have had. The first one is that the equations that we've been working with have always been in terms of radians. Yes, you can write your equation in degrees, and in physics I think that's actually more popular. But for our purposes, and generally if you go to calculus as well, our trigonometric equations will be in terms of the angle in radians. Again, for the examples that you'll see later, they'll be in radians. Second, please check your answers while you're going through these. So if you weren't sure how I got one, or if you had tried one on your own and you weren't able to get the right coordinates that I had, that I was able to calculate, plug in that point into the actual function, use the unit circle, and try to actually figure out the appropriate y value. Please make sure you're checking your answers on your own. I know I've only done that once or twice in both videos so far. Try to check that on your own more frequently. I'm not able to check as frequently because I do want to make sure that I limit the amount of time in this video. Third, please pause frequently to process because there's a lot of information going on. There's also a lot of fractions that we're manipulating that you may need to just process individually. Pause frequently if you need to understand what's going on. And finally, please practice these problems again on your own. It's a little bit easier to do when I'm actually guiding you through the problem, but when no one is there to guide you and you only have yourself, it might be a little bit more difficult. And the difficulty that you experience in trying to solve the problem on your own could actually be really beneficial. So I can't stress this enough. Please try to practice those problems on your own because that will be beneficial in the long run. Okay, in this unit, in this section, we have 8 problems to knock out. Let's start with number 1. Y equals negative sine 2 pi over 3 times x. I'll give you I'll just let you know. If you'd like to pause the video at any time during this, feel free to. I'm not going to request that you pause the video at all during these problems, simply because they're kind of tough and I just want to make sure that you have guidance throughout them. The amplitude. The number in front of sine is going to be a negative 1. So we do want to eye that. Notice we do have our negative, so we want to be careful with that. Our amplitude will be the absolute value of negative 1, which is 1. Our period will be 2 pi divided by the b value, which is 2 pi over 3. Notice that the 2 pi's, once I multiply by the reciprocal, will be on the top and bottom, and I cancel and be left with the period of 3, which means my intervals will be the period divided into quarters, or 3 over 4. Okay, next, I'm going to have my amplitude of 1, which gives me my range of negative 1 to 1. I don't need to go up or down because there's no number on my equation that moves this graph up or down. I'll go and do my intervals. This is 3 over 4, going out to 1.5, 2.25, and 3. Going back the other direction will be the same thing. Finally, my sine function, because I am working with sine, will always start at the origin. I have a choice of going up or down. Remember that the negative 1 is going to prevent me from going to a max first. I'll actually be going to a min for my sine. So I'll have 3/4 negative 1, and then the rest continues. And hopefully this problem didn't prove to be terribly difficult. Now I believe I only had to graph one period of this, so I'll graph one period in green here, and then we'll move on to the rest. Either the green or the orange is all you needed for the problem. Next problem. Negative 10 cosine pi over 6 x. Again, I will note the negative. That's going to be important. Not at the moment though. The amplitude will be the absolute value of negative 10, which is 10. The period is going to be 2 pi divided by pi over 6, which is the b value. And I'll go ahead and multiply by the reciprocal. And it looks like that this will give me a value of 12. So this is a much longer period than we've had before. The intervals will be the total period divided by 4, which is going to be 3. These are nice numbers to work with, so we're going to keep going. There is no vertical shift, so I don't have to worry about modifying the y-axis. And I do only need one period, so I'll have my amplitude be 10, which gives me a range from negative 10 to 10. The intervals will be in 3, so here's a 3, here's a 6, a 9, and a 12 for the 4 parts for the cosine. The cosine does not start at the origin like sine does. The cosine starts at its max or at its min, depending on whether your coefficient of the function is positive or negative. Because our coefficient is negative, we will not start out at a positive 10, we indeed will start out at a negative 10. And then we proceed to 3. We'll have a coordinate of 6, 10, of 9, 0, and a 12, negative 10. And here's my 1 period for cosine. This one I'll double check because I do want you to get in the habit of being able to check your answers. So we will have negative 10 cosine of pi over 6 x. And I should get a value of 3, 0 and of 9, 0 to be my intercepts, and 12, negative 10. So it does look like my answer is correct. Next problem. No negative for 3, so I can just jump right into it. My amplitude will be a 3. Here, I want to look at, I have a horizontal shift, so I got to be careful here. There's a 1, remember, in front of that x. If I factored out the 1, it would be the same function. So my period is going to be 2 pi divided by the 1, which is going to be 2 pi. My horizontal shift will be pi, but to the left. We're to the left this time because we have a positive pi, and a positive number inside the parentheses for the function will be opposite of what we're thinking. So instead of to the right pi, it will be to the left pi units. The interval will be our period divided by 4, which is pi over 2. We don't have any vertical shifts, so we can go ahead and graph our amplitude as such. My range will be 3 and negative 3. But before I start the x values, I want to just do some work on the side. My starting value was going to be pi. But if it's pi to the left, that means I'm actually starting out at negative pi. So let me do a negative pi. That means my first point, when I add negative pi plus pi over 2, that's the same thing as negative 2 pi over 2 plus pi over 2, which is going to give me a negative pi over 2. My second point will be a negative pi over 2 plus pi over 2. That's going to give me 0. How many of these do I need to do? No one can hear you, but except for you, of course, you need 4. The third point will be 0 plus pi over 2. That's going to be a pi over 2. And your fourth will be a pi over 2 plus another pi over 2, and that's going to be 1 full pi. So let me go and label these. My starting point was negative pi, and then I had a negative pi over 2. Then I had a 0, and then I had a pi over 2. And then I had a pi. Okay, next. I am working with the sine function. The sine function usually starts at the origin, but this one starts at negative pi because of the horizontal translation. So I'll start at negative pi 0. The positive 3 tells me I'm going to go to my max first, so negative pi over 2 will be up here. For the origin, for x equals 0, I'll have a y value of 0. Pi over 2 will be a y value of negative 3. And then pi will conclude the cycle. There you go. Now I'm going to try one more, and then we'll break the last 4 into a new video. Y equals negative 3 plus 5 cosine pi over 12 x. This one looks tough. No, it doesn't. I was just kidding. It doesn't. Amplitude, 5, because of the coefficient of cosine. The vertical shift, this might have been our first one. We're going to go down 3 units. Our period. No horizontal shift inside, which is nice, so I have to do 2 pi divided by the b value. And when I multiply times that reciprocal, my pi's are going to cancel, and I'm going to get the longest interval the longest cycle that I've had so far of 24 units. That's how long my period will be. My interval will be 24, the period divided into 4s, which gives me 6. Okay, for the graphing part, it would usually be at 5 to negative 5, but because we have to go down 3, that means that my my range is not going to be from negative 5 to 5. Going down 3 will be at negative 2. Going down 3 here will be at negative 8. And that gives me my midline, the line that's going to cut the cosine in half, at y is equal to negative 3. I might have said that this was a positive 2, and it should be. I did write a negative 2, unfortunately. So please make sure that you have a positive 2 here. Another thing I want you to keep in mind is that there is the x-axis above this line. But the x-axis I don't really care about because of the vertical shift. I'm really going to be looking at the points on the midline, y equals negative 3. And this line is called the midline. I think I've said that in the past few videos, but I've never actually written it down. So that line is the midline. It cuts the cosine graph or the sine graph directly in half horizontally. Let's go and set up our intervals. My interval is going to be on 6's, so I have a 6, then a 12, and then an 18, and then a 24, like 24 hours in a day. I'm starting with a cosine graph, which means that I'm not going to start at the origin. I'm going to start at a maximum or a minimum. My plus 5 tells me that I'm going to start at my max, so I'll start up at positive 2. At 6, I'll have a y value of negative 3. 12 will be a y value of negative 8. 18 will have a y value of negative 3. And 24 will be a y value of a positive 2. Let me connect those. And there you go. That is one full period of negative 3 plus 5 times the cosine of pi over 12 x. Thanks for watching, guys.